Hi everyone! In this video, I will be going over my project to explore how big data and weather forecasting can come together. Weather has had a significant impact on all individuals. Making this topic especially interesting is that weather forecasting has been attempted well before big data has even become a possibility. In today's video, I will cover the necessity of proper forecasting and why it's important for us to improve. Next, we will go over the big data methodology and why it's a perfect fit for weather forecasting. Following, we will explore the data resources that I use to collect and utilize for this project. Then we will go over the code itself to see how the data source was set up. This includes going over the Python script line by line to see exactly how it was set up and utilized. This will be really important to note as we go over the conclusions I state at the end of this video. Afterwards, I will present the findings I found. I will offer 2 points in particular to focus in on. Why these results were chosen will be focused on and discussed later. Lastly, we will review the project's successes, shortcomings, and recommendations I offer to those who wish to improve on my work. So let's begin. In the 1900s, the deadliest natural disaster in U.S. history occurred in Galveston, Texas. Due to improper forecasting, Galveston lost roughly 8,000 people when rudimentary forecasting techniques assumed an oncoming tropical cyclone was a small thunderstorm. When the tropical storm approached, officials debated whether or not to evacuate the barrier islands. Forecasting officials dismissed the lowering barometric pressure to a small thunderstorm and called off the potentially life-saving procedure of having the barrier island evacuated. Should weather forecasting procedures have been more effective and more advanced, this devastation could have been avoided. One of the biggest sources of difficulty was the lack of readily known historical patterns to call upon. This problem, though, is not relegated to just the past. The issue of weather forecasting has still not been solved. As recently as November 15, 2018, forecasters miscalculated the intensity of the nor'easter that pummeled New York and New Jersey. What called for a light dusting of snow, the storm punched closer to a foot of snow, killing several stranded drivers. When weather plays such a significant toll on life, a better forecast can save thousands of people each year. We will work to improve the possibilities of seeing into the atmospheric future. Utilizing big data is the perfect fit for weather forecasting. Unfortunately, forecasting is not an exact science. Models are formulated using equations from physical properties and historical context. It is the intuition that meteorologists can offer that is derived from past experiences that can create the best product for forecasting. This is difficult to exactly nail down in either an equation or a computer setting. Forecasting now benefits from the millions of data collection centers and weather sensors around the United States. This produces billions of data points each day that can be used for getting a better understanding of what's happening in the atmosphere. Combining this data into a single repository can be difficult for analysis. While there are sources that offer historical data, the data is not structured for easy analysis. Weather data collection creates data at a high volume and high velocity. But these large volumes of data are necessary for creating better forecasts. It is our goal to create a single repository that can handle large amounts of data in an easily accessible way. In this project, I utilized Weather Underground to source my data. You can visit Weather Underground at www.weatherunderground.com. It offers historical data on any city within the United States. Weather data points offered include high temperature, low temperature, precipitation, dew point, wind speed and direction, barometric pressure, and many more. These are all the perfect points to focus in on for a forecaster to utilize. With a simple URL pattern, we are able to create a Python script that should be able to grab the weather data for our data repository. Should we need further data, I am considering NOAA. The National Oceanic and Atmospheric Administration is a government agency that could provide more data points such as water temperature in the U.S.'s surrounding bodies of water. This could prove key to forecasts such as a Galveston tropical cyclone of 1900. For the first step, I created a file which was named weather-data. This is a text file, and I intended to write into it, thus the W at the end of the code. Next, in order to collect data from Weather Underground, I must create a place for the data to be stored. This means I had to iterate and make a date range for my data to be stored. It is important to note that not all years are the same length in the number of days. To account for leap years, I had to specify several conditions based on the number of the year. You can see them here. Lastly, we checked to see if I had already iterated through each month before continuing on to the next month. This includes not iterating past 29 days for February if it is a leap year, not iterating past 28 days in February if it is not a leap year, and not iterating past 30 days if it is April, June, September, or November. Next, we create a variable URL for stripping weather data as I discussed earlier. This is one of the reasons why Weather Underground was chosen as a data source. Its simple pattern follows location code, year, month, day, / dailyhistory.html. It is at this point I see the first problem. While it is easy to strip data for a single location, I am unable to strip multiple locations into a single repository. Location data must be already known. Stripping all locations around the US would prove too vast if manually inputted. We can see the solution is not going to be scalable for the size of the problem, as we have seen before. While a full, complete data analysis may not be possible, I still want to prove the concept that weather forecasting can benefit from big data. Here, I have changed my goal of my project to encompass just Boston. The code now utilizes the package Beautiful Soup, a web scraping package within Python, which must be imported. To format the timestamp and scrape the daily high temperature observed each day, I invoke Beautiful Soup. Climate change is causing hotter summers. Although I'm not working with enough data, I can begin to outline the process of observing the summer's increasing high temperatures. To do so, I clean the data and alter it for a CSV file that can be read. To create a plot, I use matplotlib, a plotting package in Python that must be imported. I set up the axis to be labeled and provide the table title. A representation of the results can be seen here. Visualizing the average temperatures of each month, we can see July has the highest average temperature. This is followed by August and June. I wanted to narrow down what is occurring in the month of July. By breaking down the month of July by each year, we can see which years are experiencing higher than average temperatures. We may be able to even see an upward trend. By breaking down the years and filtering out the dates of each July, we can create a result that prints the total high temperature average for each year's July. This is repeated for 2015, 2016, and 2017. Once completed, we see that 2016 experienced the warmest July. There were several drawbacks that occurred in the project that proved inefficient for my big data ambitions. First, the approach was not scalable. I was only able to successfully look at one city at a time. A large approach is necessary. If I had a full list of the city code names, I may be able to create a code that inputs the code in each city into the URL, creating a wider data set. Next, my approach had a low refresh rate. Either I would need to manually change the date range each day, or create a new method that simply appends the last information created to an existing data frame. The append method is almost mandatory when working across the millions of sensors across the United States. You could not rip the data of all sensors for all time each day. Lastly, Python does not offer the best analysis techniques. R or Tableau have more intuitive analysis options. R is a statistical language, and Tableau creates more easily interactive graphs, something important for meteorologists who may not code. Sticking with just one language was a mistake for long-term success. A combination of Python for web stripping and R or Tableau for analysis would be optimal. Collecting the data is just the first part of big data analysis. Doing something is what creates results. This project sought to find a way to create a single data repository for weather data that could strip online sources to create easy analysis. It was not completely successful, but found that Boston experiences its warmest month in July, something that is not the same around the US. It also found Boston's warmest July in the previous 3 years was in 2016. Forecasting improvements can occur when we improve our data analysis opportunities by enabling meteorologists with the most information. With recommendations I offered, and some you may prescribe, this may be something we can do. Thank you.